Hi, welcome to howtostats.com. In this video I'm going to perform a factor analysis. I've done a previous video series based on principal components analysis, but this time I'm going to perform a factor analysis. And very briefly, the distinction between principal components analysis and factor analysis is that in principal components analysis, you're reducing data in order to explain the total variance or total variability associated with each variable included in the analysis. Whereas in factor analysis, or what people sometimes call common factor analysis, the only percentage of variance that's included into the model is that variance that's shared between the variable and the other variables included in the analysis. So it's a fairly fundamental difference between the two approaches. The correlation matrix upon which the analysis is performed is different because the diagonal elements on the correlation matrix are different. You put your estimates of communality, if you will, to start the analysis in common factor analysis, whereas in principal components analysis it's always 1.0 because you're trying to explain the total variance. Anyway, I'll probably put together a video series describing exactly what the difference is between the two in a more lecture style format. But for this purpose, I'm going to assume that you know the difference between the two and that you know you want to perform a factor analysis and not a component analysis. The data I'm going to analyze in this example are real data. They're based on an assessment called the Toronto Alexithymia Scale, which is a 20-item inventory. And myself and a couple of colleagues published a paper based on these data where we performed, in fact, a confirmatory factor analysis rather than a factor analysis. But I thought it would still be quite useful to use these data for the factor analysis. I think in particularly because I plan on doing another video series based on confirmatory factor analysis, and you can look at the differences and the subtleties and the differences in the results between the two. Again, there's probably a lecture that's required to explain exactly the difference between unrestricted exploratory factor analysis and confirmatory restricted factor analysis, but I won't go into that detail right now. So here are the variables. They're all in the columns, so the items are in columns, and I've got the subscales here in the total scale. So that goes from item 1 to 20, and I've got my cases that are going all the way down in rows, and I've got 355 people in the sample. So that should be big enough for an analysis based on 20 items. It's not huge, and I would even argue that when you are analyzing at the item level in a factor analysis, it's even more important to have a large sample size. You can't get away with small sample sizes when you're analyzing at the item level, in my opinion, because the correlations tend to be relatively small between the items. So you really want a large sample size to examine those types of correlation matrices. Alright, so just as in the principal components analysis approach, in factor analysis, in unrestricted exploratory factor analysis, you're stuck with the first step of trying to figure out how many factors to extract in your analysis, your factor analysis. So you have to, in step one, you can, as I did in the principal components analysis, you can look at the scree plot. But I've also done another video series where I did a parallel analysis, and I encourage you to look at that so that you can figure out how to do a parallel analysis, because I would argue that it's the most sophisticated approach to determining the number of factors to extract in a factor analysis. And what I used in the other video series on parallel analysis, or a Monte Carlo simulation of eigenvalues, is a macro that was developed by Brian O'Connor, and I'm not going to tell you where you can find that because in the other video series I've got it, but I'm just going to do that now. I'm going to do the parallel analysis. I'm going to assume that you know how to do that because you've watched the other video. So I'm going to specify my items, which is I1 to I20. I've got 20 variables, 20 items in the analysis, and I'm going to change this to 5,000. I want to keep the 95%. I want to keep this a 2 because now I'm doing principal axis common factor analysis rather than component analysis.